So yeah, what we saw before were erosion features, and now we're going to talk about depositional features. I kind of kind of messed up here because I already talked about moraines, but moraines are depositional features. They are created by material that is transported by the ice. And this slide details a bit more what I was telling about moraines. So you have a glacier that's making a U-shaped valley. That is an erosional feature, but it is also creating moraines, and that's depositional feature. So a moraine is a ridge or mound of debris deposited by glacial ice. And there are three types of moraine. We already talked about the medial moraine that's kind of surrounded by ice on its sides. We have lateral moraines that has rock on one side and ice on the other. We have the same here. And if we go upstream, ice and then rock. And terminal or end moraines that are all the moraines that are just at the front of the glacier, where the glacier is really looking like a bulldozer and pushing all that material in front of it. Medial moraines are particularly big when it comes to tidewater glaciers because there's a lot of sediment being eroded. Usually tidewater glaciers are pretty big glaciers. And as we said in the last video, the lateral moraine, when the glacier that's creating it is merging with another glacier, or with a tributary is merging with another tributary, it can create a medial moraine, kind of trap the moraine in the middle of ice. Yeah, it's just an image showing you how a terminal moraine is advancing with the glacier, because the glacier is constantly pushing that material away, depositing it, kind of also eating that moraine away, but there's always some kind of material in front of moving ice like that. The nice thing with terminal moraines is that they can tell us a lot about the advances or retreats of a glacier. If you think of a terminal moraine, let's take this glacier for example. Let's say this glacier advances a lot because the climate is favorable for that. Then it will reach a maximum extent that will be this kind of moraine. And so basically everything that is before that moraine is flattened. It retreats, it leaves a flat surface and is going to advance again, but not as far, and create a second moraine, which is that one. And that's also the furthest it will go for now. And then it retreats again, pushes another moraine and creates another end moraine here. Now, if the glacier was to advance a lot and past the maximum extent it already went to, it would basically erase those three moraines, which is why whenever we see end moraines, we know it's a temporary maximum in a way. There's nothing telling us that the glacier never went. I mean, there's nothing telling us that the glacier would not go further than its terminal moraine right now. It's just kind of the trend is now glaciers are retreating everywhere in the world. But basically, we can use those end moraines to date with the maximum extent of a glacier at a specific time, because we can do some datation of those rocks, in those moraines. We can use the vegetation that's growing on it. We can measure at which point the material that was being eroded was exposed to the air and to the environment. So terminal moraines or end moraines give us very precise information about when a glacier was to where it was extending to for the last time. There's also like just a note about medial moraines here. They're formed when two tributaries merge into a single branch. So you take this moraine here. In that case, it's a medial moraine. In that case, it's a medial moraine. But once the two tributaries merge, it becomes a medial moraine. Another interesting thing about basal erosion is that it also those landforms can tell you, like the striations, information on the direction of flow. In general, when you look at how a glacier erodes the bedrock, you have that typical thing that happens where you have that's what we call, I think, the lee side and something else. But basically, you're taking some material from upstream. It's kind of building up a ramp, and depositing the material here. So if you have an obstacle, it's going to erode in front of it, go over it, and then deposit some stuff behind it. And you can see that with let me jump to the drumlins. I'm going to come back to the erratic after. That's typically what happens with a drumlin. You have what we call the stoss end and the lee slope. So here we have a depositional feature that is kind of also a bit erosional, but it's depositional feature where you had a glacier that was flowing on top of that hill at some point. But that hill was created because it has like that typical steep slope on one side and more gentle slope on the other side. And what it tells us is that that steep slope between A and E is the place where the glacier was eroding a lot. And it was depositing after that on the lee slope all the material. That's why the lee slope is more gentle, is because the glacier deposited material, took material from between the points A and E, and then deposited all of that between the points E and B. It's kind of counterintuitive with this figure. This figure represents the early stage of an obstacle beneath the glacier, meaning that as you speed up in time, you go forward in time, this side where you have the abrasion is going to be steeper and steeper and steeper. And all that material is going to be deposited on the quarrying side where you have that blue shape, and you're going to create a more gentle slope on the side where the sediments are brought to, which is why drumlins like that, which are deposited sediments, often with a bedrock core, really show us the direction of the ice flow from previous glaciation. Wherever the slope is gentle is where the ice was going, and wherever the slope is steep, that's where the ice is coming from. Another things are erratics. Erratics are basically rocks that have nothing to do here. Like you're in the middle of flatlands and you have a giant rock that's kind of standing here. You know, it's not merged with the ground. It's a rock that eventually you could move away if you were a giant or something like that. But what is it doing here? How did you end up with a situation like the one on the left? I'm going to tell you that's not a river or anything like that. That was deposited by a glacier. And if you remember what I said for the striations, where you have rocks embedded in the ice that erode the bedrock and make the striations, that's the exact same process. You can have gigantic boulders that are trapped in the ice and basically moved along with the flowing glacier. And that's even more impressive when you look at the past glaciations, where you had gigantic ice caps covering North America or Northern Europe, and you would have gigantic rocks moved very far away by the ice sheets, which is why sometimes maybe in the middle of Illinois or something like that, you have a rock in the middle of nowhere, because at some point the ice was extending to here in the last glaciation. Just two quiz preps to finish that section of the lecture. So steep ridges composed of glacial till along the sides of the glacier are called, I'm gonna give you a few seconds. Those are called lateral moraines because, well, at the side of the glacier. Steep doesn't necessarily mean drumlin. A drumlin would appear typically, if I come back to that kind of image, a drumlin would typically appear at the bottom of the ice, something like that, and not necessarily, you know, from a U-shaped glacier. But you can have that. Drumlins can be as small as centimeter, as long as a few centimeters, or a few hundreds of meters. Drumlins are very strange features. It's kind of same thing for the erratics. You can have small pebbles transported by a glacier, or giant boulders like that. But the clue here is that we are talking about the sides of a glacier, meaning that on the sides of a glacier you have ice on one side and rock on the other side. And if you remember the definition of a lateral moraine, that's what it is. So the answer here is answer C. It would have been answer B if we said composed of a glacial till in the middle of a glacier, surrounded by ice. That would be a medial moraine. Oh yes. So we're gonna talk about that in the next slide, in the next section.